Hey guys, today we're talking about discrete functions. So we learned about identifying functions on Friday, and now we're going to move on to talking about discrete versus continuous. So today we're going to talk about discrete functions and discrete data, and tomorrow we're going to talk about continuous functions. So when we were identifying functions, our main rule was that x's do not repeat. If you repeat your x, you're not functioning in the head. X's do not repeat. We learned about the VLT test, vertical line test, where you draw vertical lines to see if the graph crosses more than one time. If it crosses more than one time, it is no longer a function. Now we're going to move into those different types. So discrete data. This is disconnected data. And discrete data is data that is counted. Data that is counted. So these you can't have halves, you can't have decimals. This data is only whole numbers. So on a graph, these are going to be points. Whoops. Let me go back, maybe. Hang on. There we go. These are points that are not connected. So they're separate points. There's not lines drawn between the 2 points, because if I start drawing lines between things, then we're going to have halves. We're going to have 3.2, 3.236. And disconnected data is things that are not connected. There's not measurement. So I like to think of discrete data as counting, and then continuous data, which we're going to talk about more tomorrow, but continuous data is data that is measured. So anything that you can measure would be continuous. Your height, your weight, pounds, inches, time, anything that can be measured is continuous, because we could have 5 foot 4 inches. You could have 3.5 seconds. But if you look at this example, we're circling examples that are discrete functions. So if I look at number 1, it says the number of children in a household. Would that be discrete? Well, continuous, again, is halves. It can have seconds, milliseconds, any kind of decimal fractions. Can we have half a child? No, that doesn't make any sense. So it would be discrete because it's only whole numbers. So this one would be discrete. If I look at number 2, though, it says the height of the children. Well, height is a measurement. That's continuous, because I could have 3.5 feet. I could have 3.75 feet. So this is continuous. So that's not discrete. Time in a race. Again, time is a measurement. I could have 3.5 seconds. That is not discrete. That is continuous data. Time keeps going. There's not separate points. I'm not going to start at 1 second and skip to 10 seconds. The time keeps going. It's continuous. So that is not discrete. The number of apples. Number of apples would be what? Can I count them? Remember, I said discrete was counted. So yes, I can count number of apples. 1 apple, 2 apple. 5. Remember, like we said up here on a graph, points that are not connected. Look, I've got 2 points right here that are connected all along this line. So I've got points right here in the middle that are a half. They're not a whole number. So that is continuous, not discrete. Here I've got specific points that are plotted on the graph. That is discrete data. Yes. So that's discrete. Now we're going to move on to talking about domain and range. The domain are all of the x values of a function. While range, if domain's x, then range has to be all the y values of a function. So domain is x, range is y. Domain is x, range is y. So if we're looking at domain and range in discrete value and discrete functions, we use these fancy brackets. They look like this. Fancy brackets. They're kind of hard to draw, so if you just give me some squiggly lines, that's perfect. And you put all values for domain and range in those fancy brackets. So let's try some examples. Let's look at number 7. So number 7 is asking for the domain and range down here. So they went ahead and drew this fancy bracket for you. So first, all we're looking at is domain. And domain, again, is your x value. So all I care about is x values. Points are written in x, comma, y. Think of the alphabet, x, y, z. So all I care about is this first number that's right here. So I'm only looking at these first numbers. And that's all I'm going to put in those fancy brackets. And you just write them like this. -1, comma, 5, comma, 2.3, comma, 4. There's my domain. My domain, all my x values are right there in those fancy brackets. Then I look at my range. The range, remember, is the second value. If right here, that's y. So all I'm looking at are these second values. Now notice I have positive 9 listed twice. When you go to write this, you do not have to write 9 twice because you're just asking for the y value, the numbers, and we don't care how many times. You're just trying to figure out where it touches on the y. So you can just write 9 one time and it covers. So if you've got multiple values or all of your y's are the number 9, you would just put 9 one time. Do not put repeats. All we care about is, again, what values it's hitting, not how many times. So that's with ordered pairs. Number 8 has a table, which is the same thing, except there's this fancy thing here, which we will get into more detail with on Thursday and Wednesday. We've got x values. X values are right here, right? So these are all my x's. Let's go ahead and list those. That's normal. -3, comma, 5, comma, 8, comma, 9. Then we have this. F, and then there's parentheses x. And the way you pronounce this is f of x. I'm not going to get into too much detail because we are going into more detail later on this week when we start finding functions, but this is f of x. So it's saying I'm putting my x values in, and when I get them in, these are the numbers that I get out. So these are going to be my y values. F of x is just a fancy way of writing y, just a new way of writing y. That's all that is. So if you just want to write y on top of there, that's fine with me. So these are all the y values. 4, 2, -6, and 8. That's all you're doing. You're just listing domain and range. And here's a map. So remember how maps are read? I've got x values are always on the left, y values are always on the right. So I've got 2 is going to 3. So if you have trouble reading these, I would just map them out, and then I would write the ordered pairs. That way it's easier to see if you're having trouble with it. -1, follow the arrow, goes to -5. So -1, -5. Then I've got 4, 10. 4, 10. And then I have 5, 3. Well, is that a function? Yeah, because each x is only getting off at 1 y. I have 2 kids getting off at bus stop 3. That's okay, but each of them is only getting off at 1 bus stop, so that works. So again, let's go ahead and go through this. X values are the first value. So I've got 2, -1, 4, and 5. No repeats, so we're just going to write those out. And then I've got my y values, which are my second values in the points. And I've got 3, -5, 10. And again, I've got 3 again, so I'm not going to list it again because I don't need the repeats listed. That's just extra information we don't need. And that's it. Super, super easy, y'all. Okay, so next I've got a graph. So first you're going to need to know what these points are located at. So if you look on here, this one is over -1, -2, and down -1, -2, -3. So this point is over -2, down -3. This next point is over 1, 2, 3, 4, 5, 6, and up 1. Over 6, up 1. And point number last is located up 5 over -1, up 5. So there's my points. So I've got -1, 5, 6, 1, and -2, -3. So if I look at my x values for my domain is x, range is y. I've got domain is -1, 6, -2, and range is my second value in those points, 5, 1, and -3. So there we did ordered pairs, we did a table, we did a mapping, and we did a graph, all of the above. Now there's more words for domain and range, x and y. It's great in math. We have so many different words for the same exact thing. So independent variable. This variable represents the x value. Independent. He's by himself. He does not depend on anybody. The dependent, the variable that represents the y value. And this value, the y value, is dependent on what the x value is. So if you think of my fancy function machine I made and I showed you, and I plugged in a number, and then out came a different number based on the rule, and our rule was 2x plus 1. So if I plugged in a 1, I popped it in there, it was 2 times 1, which was 2, plus the 1 would be 3. So I plugged in a 1, out came a 3. So my input, or my x value, the independent variable that went in, was x, and depending on what number I put in, out comes the other one. It depends on the x. That's what the y means. So independence x, dependence y. So we've learned that x, another name for x is domain. We've learned that another name for x is independent variable. We've learned that another name for x is input. And then for y, we've learned that another name for y is range, dependent variable, and output. So we've learned all of those things. So let's look at number 11. It says the function y equals -3x plus 12 represents the amount y in fluid ounces of juice remaining in a bottle after you take x gulps. So independent variable. Well, independent, remember, is our x, so our independent would be what? X, our gulps. So that means our dependent is our y, which would be the amount of fluid. Amount of juice remaining. Juice remaining. This, remember, independence x, dependence y. So if you think about it, if I take 3 gulps, well, then I'm going to have less juice than if I took 2 gulps. So it depends on how many gulps I take in order to know how much juice is remaining. If I take 10 gulps, there's going to be way less juice than if I had 3 gulps. So that's why the juice remaining, is dependent on the number of gulps that we take. So if we look here, we've got a domain of these numbers, and it wants us to find the range. Well, how do we do that? It's given this equation, though. Domain numbers are x values. So if I've got an x value of 0, can I just plug 0 in everywhere I see an x in this formula and figure out then what the y value is? Let's try that and see if we can do that. So I've got y equals negative 3x plus 12. And I'm going to plug in 0 everywhere I see an x. So y equals negative 3. Instead of x, I'm putting 0 plus 12. Well, negative 3 times 0 is 0, so I just get 12. So my first range is 12. If I plug in 0, I take 0 gulps, I'm going to have 12 ounces of juice remaining. Okay, let's try another one. What if I, instead of taking 0 gulps, what if I take 1 gulp? So everywhere I see an x, I'm going to put 1 plus 12. Well, negative 3 times 1 is negative 3 plus 12. Negative 3 plus 12 is 9. So now if I take 1 gulp of juice, I'm going to have 9 ounces of juice remaining in my cup. The next one is 2. So negative 3. Instead of x, I'm going to put a 2 plus 12. Well, negative 3 times 2 is negative 6 plus 12. Negative 6 plus 12 is positive 6. So if I take 2 gulps of juice, I'm going to have 6 ounces of juice left. Next, I've got 3. Negative 3 times 3 plus 12. I've got negative 9 plus 12, which is 3. And then number last, I'm going to plug in 4 everywhere I see an x. So negative 3 times positive 4 plus 12. Well, negative 12 plus 12 is 0. So after 4 gulps of juice, all of the juice in the cup is going to be gone. And I can tell that based on plugging in my values. And all I did was plug in these x values into my equation. Everywhere I saw an x, that's what I plugged in to figure it out. Let's try number last. The cost y in dollars of a movie ticket is $8. Each person can purchase a maximum of 5 tickets. Find the domain of the function. So domain is our x values. That's what we can plug in. So y is the dollars. That means x has got to be the movie tickets, right? So what's the least amount of movie tickets we could buy? 0. Nobody could buy tickets. That's totally possible. So remember, we draw these fancy brackets. I could buy 0 tickets. Could I buy 1 ticket? Yeah, we could just buy 1. What about 2? Yep. 3? Yep. 4? Sure. 5. What about 6? Could I buy 6? What did this say up here? The max we could buy is 5, so that's it. The domain would be anywhere from 0 to 5. And remember, it's not a continuous, it's a discrete function because I can't buy half a ticket. Either you buy 1 ticket or you don't buy a ticket at all. There's no half tickets, there's no 3/4 of a tickets. You're buying 1 ticket. So that is my domain. Those are my x values. Well, then I need to find the range, right? So to find range, it cost, what, $8 a ticket? So y, the money, equals 8 times however many tickets we buy. And we don't know. That's our x. So there's our equation. So I just have to plug it in to find it. So I could buy 0 tickets. Well, 8 times 0 is what? 0. So there's that. What if I bought 1 ticket? 8 times 1 would be 8. Oops. What about 2 tickets? 8 times 2. 16. 8 times 3. 24. 8 times 4. 32. And then the last one, because 5 is the max number of tickets that I can buy. The problem told me that. 8 times 5 is 40. And close it off with your fancy brackets. So there's my domain, X values, and then the range was after I got my domain, I plugged in those X values into my equation to get my range, because my range is my dependent variable. It depends on my X value, which is my independent variable, correct? Now it wants me to graph the function. So down here we've got number of tickets, that's my X. And then cost in dollars, that's my Y. So let's go ahead and number this. 1, 2, 3, 4, 5. That's how many tickets I could buy. So I'm going to stop there. And then I'm going to count by 8s because that's how much tickets are cost. 8, 16, 24, 32, and 40. So if I buy 0 tickets, I pay $0. There's a point, right? 1 ticket's 8. 2 is 16. 3 is 24, 4 is 32, and 5 is 30. And notice I'm not drawing a line between the data because why? It's disconnected data. It's discrete data. I can't have these little half marks. I can't have half a ticket. That doesn't work. So it's just discrete. There's no line in between them. And again, we've kind of already answered this. Why is this data discrete? Because you cannot buy half a ticket. Doesn't work. You either buy a ticket or you don't buy a ticket. So recap, discrete data is disconnected data. They have no connection. Data that is counted. If you can count it, it's discrete. And these are, if you look at it on a graph, they're points that are not connected. There's no line connecting the graph. So we talked about number of children in a household is discrete data because you can't have half a kid. Number of apples, you can count that. Anything that's measured is not discrete. So height, time, anything like that is continuous, which we'll talk about tomorrow. Then we kind of talked about domain and range. Domain are X values, range are Y values in a function. And we know how to find those from ordered pairs, tables, mappings, and graphs. And you can, the way you write these is with those fancy brackets. And you put all your domain values in one and all your range values in the other fancy brackets. If you have multiples, you do not need to list them multiple times. If I had 3 9s, I would not list all 3 9s. I just need the 1 9 because we're just telling what values are there, not how many values. Then we talked about another word, so we learned domain and range. Domain is X, range is Y. We also learned that the independent variable is X and your dependent variable is Y. So the statement Y is a function of X means that Y is dependent on whatever X is in my function machine. When I plugged in X, Y was dependent on whatever I plugged into my function machine. Just like our example with number 11, we talked about the gulps of water or gulps of juice and the amount of juice remaining in the cup. The number of gulps depends on how, the amount of juice remaining depends on the number of gulps that we have. And then we had this example here where we talked about the domain of the situation was 0 through 5 because 5 was the max number of tickets and 0 was the least amount. We could buy 0 tickets, right? And then we wrote the equation for it was y equals 8 times however many tickets because each ticket was $8. And then we plugged in our domain, our X values, into X, all these values we plugged in to find our range. Then we plotted the points, and the reason the data is discrete is because you can't buy half a ticket. There's no halves in it. It's either you buy a ticket or you don't. And that is discrete functions. Bye, y'all. Have a great rest of your day. Work on your homework on Go Formative. It is 3.2 discrete functions.